So let's go through a couple definitions now. First one we're going to talk about is called head. And that is the relationship of the energy that is in an incompressible fluid like water to the height of an equivalent column of that fluid. So in fluid dynamics, head can be measured by the height to which water rises in a column when directly open to the water. So think of a water tower. You're essentially raising water up above your head so that when you open a faucet, you have pressure and you have water coming out at a good amount of pressure. And the next thing we want to take a look at is what's called static head. And that is the potential energy of the water at rest. And it's measured in feet of water. And it's a change in elevation between the source and between where it's being discharged. So an example, what's the static head at a residential supply line if the water level in the elevated tank is 943 feet, and that's at the bottom of the tank of water, and the supply line is located at 890 feet. And how you calculate the static head is you take the height, the highest point, 843, minus the lowest point of, 943, minus 890, which is the lowest point, and that gives you 53 feet of water. Now, the thing is that the water pressure isn't measured, the static pressure is measured in PSI. So we have to convert this foot measurement into a PSI measurement. And how you do that is you take the foot difference for the static head, and to convert it to static pressure, you divide 53 by 2.31 feet, and that gives you 22.9 feet, or 9 psi, sorry, in this example. So you take 53 and divide it by, well, you multiply it times 1 over 2.31, which is really you take 53 and divide it by 2.31, and that's going to give you 22.9 psi. And we know from our prior conversations that the minimum amount of psi you want to have going into a house is 40 feet. So the question is, how much static head do we need to get 40 psi of water pressure? So now what we're going to do is we're going to take 40 psi and we're going to multiply that times 2.31, and you're going to get 92.3 feet of water to get the psi to be 40 feet. Sorry, I should have said 40 psi. So you need 92.3 feet of water to give you 40 psi.